Hi, and welcome to Calculus 1. We're going to start with an algebra review because in order to be successful at calculus, calculus is not all that hard, but what students typically have trouble with is if they don't have a good, strong algebra background. So we're going to start there. This is in two parts. We're going to do part 1 in this video and part 2 in the second video. And so part 1, this worksheet, it starts off with factoring. So factoring is an important skill and you want to be proficient at it. So if this little review is not enough for you, if you look at my YouTube website, there are all kinds of factoring videos on there. So you can refresh on that. Okay, number 1 is to factor 5a cubed minus 125 times a. And factoring simply means rewriting something into multiplied form. If I take the number 6 and I factor it, I could factor it into 6 times 1, or I could factor into 2 times 3. It's multiplied form. That's what factoring is. So this is a binomial. It's got 2 terms. And so in order to factor this, we could factor out, the first step to every factoring problem is to factor out the greatest common factor. So I could factor out a 5 and an a, and that would leave me with a squared minus 25. And then this could factor further because a squared minus 25 is also difference of squares. So this could factor into a plus 5 times a minus 5, and this is fully factored. We took this binomial expression which was being subtracted and we wrote it into factored form. Number 2 goes like this: 8x cubed minus 27. This is a binomial. You would try to factor out the greatest common factor, however there's not one. But hopefully you recognize this as the difference of cubes. The difference of two things that are cubed by formula factors into a minus b times a squared plus ab plus b squared, okay? If this is this something being cubed? Yeah, this is 2x to the third power. Is this something being cubed? Yeah, this is 3 to the third power. So in this case, our a is 2x and our b is 3. So this will factor into a minus b times a squared, or 2x squared, plus a times b plus 3 times 2x plus b squared. That's how you can factor number 2. Number 3 is a trinomial: b squared plus 10b plus 21. When I factor a trinomial, I use the AC method. And so I would take a, which is the coefficient in front of the first term, which is 1, and I multiply it times c, which is the constant term, which is 1 times 21 is 21. I want to find 2 factors that will add up to be b, which is the coefficient in front of the linear term. So I'm like, I have to come up with 2 factors that will multiply to be 21 but add to be 10, and 7 times 3 comes to mind, and 7 times 3 is 21, 7 plus 3 is 10. If the leading coefficient is 1, there's no rewriting I have to do. This simply factors into b plus 7 times b plus 3, and that's factored. You can always check every factoring problem by multiplying it back together. So that is something you should probably be in the so real quick, b times b is b squared, 7b plus 3b is 10b, 7 times 3 is 21. You should check, it's worth the check to make sure the rest of your problem isn't messed up. Here is the last factoring problem we're going to look at. This is number 4. And it is 6x squared plus 19x plus 7. This is a trinomial. So, minus 7. Let me write it down right. Okay, so this is a trinomial, but the difference in number 3 and number 4 is the leading coefficient is not 1, so there's a little extra step to this. So what we do here is you take a times c, 6 times negative 7, which is negative 42. You want to see if you can come up with 2 factors of negative 42 that will add up to be 19. Well, the only way you multiply 2 numbers and you get a negative is a positive times a negative, or vice versa. So one of these will be positive and one of these will be negative. And the bigger number will be positive because when I add these, it needs to be 19. So I'm thinking about 42, and what are factors of 42? Obviously 6 and 7 are, but that won't work because 6 plus negative 7 is negative 1 or 1. That won't work. What else is there? There's 21 and 2. 21 times 2, let's see. 21 times negative 2 is negative 42. 21 plus 2, negative 2 is 19. So these are the winning numbers. This is what you do when the leading coefficient is not 1. You rewrite the middle term. 19x is the middle term. We're going to rewrite it not just into anything, but into 21x minus 2x. The order that I write these down in does not even matter. I'm just going to write it down in that order. What you do is you've created you've taken a 3-term polynomial and made it be a 4-term polynomial, an equivalent 4-term. And after you've done this, you finish this off by grouping. And so we're going to group the first 2 terms together. Oh my goodness, these are all dead. Okay, let me try another one. There we go. This and this. So if a negative falls there, it's important to keep it inside that parentheses. Factor out the greatest common factor you can from here. 3 times x is the biggest thing I can pull out there, I think. And the biggest thing I can pull out here is a negative 1. What am I left with? When you factor something out, it's like dividing it. So 6x squared divided by 3x leaves me with a 2x. 21x divided by 3x leaves me with a positive 7. If I divide this by negative 1, I get 2x plus 7. Now, if you look here, these in the parentheses here, these match. That is not magic. That is what will happen every time if you can get these numbers to work out. So now we're just going to factor out the common factor of 2x plus 7, leaving me with 3x minus 1, and that is how this one factors. This is called the AC method or the grouping method. 2x times 3x is 6x squared. 21 minus 2 is 19x. 7 times negative 1 is negative 7. So that is factored correctly. Okay, that is a little bit of factoring. Let's go through the next few. This is simplifying a complex fraction, another skill you will need to have. So right here, let's go through these. And let's see, number 6 says simplify the complex fraction. So this one, there's 2 different ways to simplify a complex fraction. And so let me see what I put on the sheet, and that'll make me decide how I want to approach this. Let's see, I think this is number 5. 8 over 5x over 3 minus 2 over 3x squared. And then number 6 is 6 over 3 over x minus 1. And then 8 is similar. Oh, I put a bunch of these. I'm not going to do all of these. Let me see. Let me do 8, which is 6 over 7x over negative 5 over 4, and I'll do 10. Negative 3c over 4. No. Yeah. Over 81 over 12c squared. Okay, so the rest of these you should try on your own. I think you should be able to do it after I show you how to do these, okay? So this is just to keep our videos not too long. I'm going to go through these. I'm going to start with number 8 and number 10 because these are simpler to do. These complex fractions, when you just look at them, they are complex. It's a fraction over a fraction. When the instructions for these are to simplify, not to solve. There's no equal sign. We're just got to make it look in a simpler form. So one approach to these is to keep, change, flip it. And so if you do that, before you do it, you have to say, you can't have something like over here. Let's look at 5 and 6. These are different. Do you see how there's a plus sign, a minus sign right there, and a minus sign right there? If something's being added or subtracted in the numerator or denominator, it is not what I call nice and tight. Nice and tight is simply a fraction over a fraction with nothing's being added or subtracted. So if we want to do the approach I'm about to do, which is called keep, change, flip, which you've probably heard that before, you can only do that if you have a fraction over a fraction. These, we could do that, but we would have to first combine the denominator into one term in both of these cases. So because of that, I don't want to do that work. I'm going to do these two in a different way. Right here, these are ready to go. So if you remember, this is a fraction divided by a fraction. So we are allowed to say it's the numerator, 6 over 7x, divided by the denominator or multiplied by its reciprocal. And so we can handle it that way. So now we're just multiplying fractions. So this is going to be 24 over negative 35x, which could also be written as negative 24 over 35x, which could also be written as the negative could be in the middle. All of these mean the same things. 24 is in the numerator, 35x is in the denominator, and the negative could be in the denominator, in the numerator, or in the middle, and they all mean the same thing. Okay, right here, let's do this one. This is nice and tight, so we'll say, okay, keep the numerator multiplied by the reciprocal of the denominator. Okay, and then we'll try to simplify this. So right here, any factor in the denominator can cancel into any common factor in the numerator. So right here, 3 can go into 81 27 times, okay. 4 can go into 12 3 times. Oh, and then this 3 can go into 27 9 times. What I have here is a negative 1 times a 1 times a c squared, or negative c squared over 1 times 9. So it could be written like this, it could be written like this, or it could be written like this. Okay, there we go. How about over here? These are different animals because they're not nice and tight fractions. So you could do the work of finding a common denominator in here, 3 over 1, and combining this into one fraction. Then we'd have a nice and tight one, and we could do that method. But when I come across this, I find it way easier to do this other method of simplification, and that's where you find the lowest common denominator of all the little denominators. So right here I have a 5x and a 3x squared. The lowest common denominator between these two would be 15x squared. In other words, could 5x go into that evenly? Yes, it can. Can 3x squared go into that evenly? Yes, it can. So that's a good lowest common denominator. What do I do with that? I multiply the numerator and the denominator by this. Because that's legal. That's multiplying this by the number 1. Down here, it's going to distribute to this term as well as to this term. So I'm just going to write it down over here. So let's see what happens. In the numerator, when I multiply 8 over 5x times 15x squared over 1, the x will go into the x squared 1 time. 5 will go into 15 3 times. In my numerator, I have 8 times 3 times x, which is 24x over 1. In the denominator, I have 15x squared times 3. Nothing canceled there. This just gets multiplied into 45x squared. 45x squared, okay. Minus, over here, 3x squared will go into 15x squared 5 times. 2 times 5 is 10, minus 10. And so this is the simplified version of that complex fraction. I'll do the same thing here. What's the lowest common denominator of all the little denominators? Well, we only have this one little x. So let's multiply the numerator and the denominator by x. What I like to do is when I come up against a whole number, I just write it like x. But when I come up against a fraction, I write it as x over 1. It's going to distribute to both terms. That's why I wrote it down twice. In the numerator, 6x. In the denominator, 1 times 3 over 1 times 1. This is just the 3 minus x. This is the simplified form of that complex fraction. Lastly, we're talking about conjugates. So I have 3 conjugates. This in general, the conjugate of a plus b is a minus b, where you change the sign of the second term. We have dealt with conjugates when we have radicals or when we have imaginary numbers. That's most of the times we deal with conjugates. So let's look at this right here. I have on the sheet, what is the conjugate of 3 minus the square root of x, 4 plus the square root of 6h, or 8 minus the square root of 3a. And these were pretty easy. Let me give you some more complicated ones. What if we have negative 2 plus the square root of 7x, or negative 7 minus the square root of 16, that is not 16, it's not 5, good one, 5. Or what if we had imaginary numbers? 8 minus 2i, 3i, 7, negative 7 minus 5i. Okay, those are the numbers. I'm going to write the conjugates in red. So the conjugates, we'll make the conjugates in red. The conjugate for 8 minus 2i would be 8 plus 2i. The conjugate for 3i, you imagine the real part to be 0, would be keep the same 0 and change the sign of the second one would be negative 3i. The conjugate of negative 7 minus 5i would be negative 7 plus 5i. The conjugate of negative 2 plus square root of 7x would be negative 2. Oops, sorry. Minus the square root of 7x. The conjugate of negative 7 minus square root of 5 would be negative 7 plus square root of 5. The conjugate of 3 minus square root of x is 3 plus square root of x. The conjugate of 4 plus square root of 6h would be 4 minus square root of 6h. The conjugate of 8 minus square root of 3a would be 8 plus the square root of 3a. So you keep the first term just like it is, you change the sign of the second term. Just out of curiosity, what does it mean if we have something like this? X plus 2 times the square root of 5. What would this be? Negative x minus 2 times the square root of 5. When you change the signs of both of them, that is called the negative or the opposite of that number. That's not a conjugate, that's the opposite of a number. So that's what that is. Alrighty.